And we have yet another problem on the screen, and you can see the diagram, and I would like to read in fact the statement of the problem. And it says, when moving from a state 1 to a state 2, the pressure and volume of 1 mole is important here, 1 mole of a monoatomic ideal gas change as shown in the figure. And P2 here is P1 by 2, and V2 is equal to 2V1. That's right. Find the dependence of the heat capacity, that is the specific heat capacity of the gas C on the volume V, and plot the corresponding graph. And we do have a graph, but it is P versus V, and we need to draw C versus V. So let's see how can we do this and try to solve this problem. First of all, I will start from first law of thermodynamics, and the statement, heat given to the system is increase in internal energy, or in differential form I would like to write like this. Heat given to the system is equal to increase in internal energy. Sorry, I misread. I misspell every time. I call it potential energy, but it's an internal energy. And internal energy is not the potential energy. It is the sum of kinetic and potential energy of a system in center of mass frame. But it's not potential energy, plus work done by the system. And if I wrote like this, I can simply, the number of mole of the gas is 1, so I would like to write dq as simply as c dt. It is nc dt, so n is equal to 1, so it becomes c dt. And du, in the earlier video I have drawn it, it will be 3 by 2 r dt. And work done, I would simply like to write it as PdV. And so we can arrive at this expression like C can be written as 3 by 2R plus P dV upon dt. This is our equation 1. And we are going to find out the derivative dV by dt using the gas law. Of course, we will be using the gas law. Gas law is always available to us. And the dependence of pressure on volume in this figure. And to do so, I can take an intermediate point whose coordinates are V, P. Simply at during the process, at any moment, this pressure is P and the volume is B. So what do I need to do? I can see the similar triangles, this triangle and the whole triangle, and I would like to write an equation in this similar triangle simply by writing P1 minus P2 is the perpendicular divided by, or I can write here like this. First I would like to involve these 2 points, and so that I can write P1 minus P by base as V minus V1, and that will become P1 minus P2 by V2 minus V1. Simply perpendicular by base, nothing else. So that we have We have what? P1 minus P, V minus P1 equal to P1 minus P2 by V2 minus P1. Just wrote it again. And we have many things like it is given in the problem. P2 is P1 by 2 and V2 is 2V1. Yeah, V2 is 2V1 and I'm going to use them at proper places. I want to write this equation, the right hand side of this equation, in terms of P1 and V1 only. So I'll be writing P1 minus P1 upon 2 divided by 2V1 minus P1, and that simply gives me the whole thing. Here becomes V1 and the numerator becomes P1 by 2. So I have a new relation like P1 minus P by V minus V1 equal to P1 by 2V1. And from here I'm going to calculate the pressure. And I can make lots of calculation here. Many steps, like I can write 2 P1 minus P V1 equal to P1 V minus V1. But I will left some steps here so that if somebody is practicing with it, he or she can go further and find P in terms of P1 and V1, and this will come like P equals 3 P1 V1 minus P1 V divided by, this is V, divided by 2 V1. This is also my statement here. And well, we also have PV equals RT, N is equal to 1. So I haven't used it, so it's time to use it. We can write PV equals RT. And if I can differentiate both sides with respect to V, it will become dP by dV multiplied by V, and plus P, yeah, you can see here, plus P, dV by dV becomes 1 equals R dt upon dV. I can write it like this. And this is one more statement perhaps we will need in future. From now I can find dP by dV from this equation, and this dP upon dV from this equation, it becomes something like P is the first term is, it will become simply minus P1 by 2V1, because first term is 3P1 V1 by 2V1, that is a constant, and the next term is minus P1 V by 2V1. So if I can differentiate it with respect to V, I will simply get minus P1 by 2V1, nothing else. So from here, from this statement, that is dP by dV, V plus P or dt by dV, I can write it V dP upon dV plus P by R equal to dt by dV. That means dt upon dV, sorry, it is dt upon dV. So I can write dV upon dt, that was required to find as R upon B dP by dV plus P, and I can put the values. I got everything ready, so it becomes B dP by dV is here, minus P1 2 by V1, so I can write it minus P1 by 2V1 plus P. I would like to write P simply from here. Here, this thing, the whole statement, 3P1V1 minus P1V. I can take P1 out, and I can write P1 here and multiply it, or not. I can write 3V1 minus B divided by 2V1. So I'm going to write this value of P here, and this will be simply as P1 3V1 minus B divided by 2V1. Yeah, this is the value of dV upon dt. And if you would like to do some steps, please do it, and you will finally get it in simplified version, like dV by dt will get is R divided by P1 3 by 2 minus B by B1. Kindly do it yourself. And so we obtained for the expression for C, and C, in this C, the first term was 3 by 2R. Yeah, from here 3 by 2R plus P dV by dt. And we are going to write down things, and I will again put the value of P from here. And after doing all those things, I'm going to get C equals 3 by 2R plus R 3V1 minus B divided by 3V1 minus 2B. Some steps are left, that is for you. And now we have an expression for C in terms of B, and we are ready to draw the dependence of C on V. And I think it will look like something like this. If I can draw C and V here like this, C and C, V here and C here, and you can see an expression that when V is equal to 3 by 2V1, you can see here, when V is equal to 3 by 2V1, that means when denominator vanishes, there will be an asymptote, C tends to infinity. So you will need to draw an asymptote at V equals 3 by 2V1, and you have to draw the graph between V1 and 2V1. So you can see here, if I can put V equals V1, and when what I'm trying to tell you, if we can put V equals V1, you will get the value simply equal to 4R. C equals 4R. C becomes 4R. And so the graph in this section is going to be, if I write here 4R, the graph between V1 and 3 by 2 V1 is going to be like, it starts from here, and it will be like this, a hyperbolic graph. And again, if we put V equals 2 V1, you are going to get C equals 2R. C equals R, simply R. And after putting, and you can see the graph decreases here. So I would like to put somewhere 2, not R, just R only, and so this point is the meeting point, and the next side of graph will look like this. This is the asymptote, and the graph must be parallel to this line. But in between 3 by 2 V1 and 2 V1, you can see here by expression dc by dv is negative, not positive. So dc by dv is negative in this part, and dc by dv is positive in this part. So this is the graph at your screen, and you know how to draw such simple graphs. So this is it. Thank you very much for watching.